Hello and welcome everyone to today's workshop on deploying cloud-native applications. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. We're excited to get hands-on and explore the cloud-native services offered by OCI. If you do not currently have an Oracle Cloud account, we've got a special promotion that I'll drop in the chat in a moment so that you can try out the services and follow along with the lab steps today. We'll also be recording the session, so if you'd like to complete the lab later on, we'll be sending the link to the recording via email shortly after the workshop concludes. If you have any questions today during the lab, please ask them in the Slack channel and we'll answer them throughout the session as well as during a live Q&A at the end. The link to join is bit.ly/join-devrel-slack. And then once you're in, you'll land in the general channel. From there, you can search for workshop-MuShop-0818 to reach our dedicated space for Q&A today. Today's lab will be presented by Adao Jr., Oracle Senior Principal Product Manager. So without further ado, I will turn it over to Adao.
Hi, hello everyone. I think everybody have the link for this hands-on. So you probably go to that one, Lab MuShop Guide. You redirect you to this lab. That's a live lab, so you have all the labs that if you want to see it, there is different tools, different applications and examples that you can follow, and tutorials, workshops, etc. Right now, you are going to Cloud-native apps hands-on when you'll be deploying a sample application that simulates a real-world e-commerce. You call them MuShop. I'll explain later more about that example. So you are going with the basics. You need to set up your cloud environment. Then you deploy the microservice app, and you navigate through the cluster and do monitoring, execute all the functions there. So you just need to click on Start, and then you'll be able to see all the steps that you need to follow. So here, a quick introduction. Today, we'll be using a managed Kubernetes cluster that we call OKE. That's the Oracle Cloud Infrastructure Container Engine. And on that example, you'll be able to deploy actually in any environments, not only on OCI. You'll be using OCI, of course, showing how to do that. But also you learn like to deploy that kind of application that can be on your local Kubernetes. Maybe you're running with Minikube, or you're running with a Docker desktop, or any other cloud provider. There is different ways that you can deploy application on Kubernetes. You can use the basic and regular YAML manifest when you have the details of your Kubernetes resources. And I'll be using today a kind of a package manager for Kubernetes that calls Helm. And that will be packing, and you select all the manifests, and they have the way more dynamically, and you deploy automatically for you. So we'll be exploring the lab. You will be exposing the app publicly, so you'll be able to see it. And you have some points with monitoring and etc. The first step is I believe that you already have created your free tier tenancy. So you'll be using this free tier tenancy. And if you don't have a free tier tenancy, if you already have a tenancy and you can use as well, you can use it. Just make sure that you have administrator rights to be able to create things, at least in your own compartment. To go to your tenancy, you just need to go to cloud.oracle.com, and you'll be able to see your tenancy. I was logging, let me sign out. Just signing again. So depending on how is your security, if you're using the ident domains, you probably will see a default here and not SSO. I'm using a federated security, but like probably you just need to enter your username and password and go from it. So let me now that you'll be able to see these. I will move my screen here so you'll be able to follow them. Be able to follow the steps and also see the screen. So, okay. Let's go on lab 1. I will be talking more about application later. It's just because when you create a new cluster, takes like more or less 10 minutes to the cluster to come up and create the nodes and have everything available. So first step, log your tenants. You just did here. Create like a basic infrastructure. Like right now, on OCI, you have your environment separated by compartments. That's a way to organize your resources. It's like your folders, different folders that you can that you see like a hierarchical way. And I suggest to you to not use the root. So else you have like a lot of things there that, and then you don't know if you created that during that's hands-on or if you created it in a different in a different task or tutorial that I've done. So the first thing is go to your menu, go to the identity security, go to compartments. You see a list of a lot of compartments, then create a compartment. And in that case, I'm using app dev. You can create whatever name you prefer. And then put a description and create the compartment. You'll be able to see that compartment now when you are using the resources. So, for example, the next step is to create your OK cluster. Next step, you'll be creating a cluster. That is different ways to create a cluster. You'll be talking more about that later. You can create using the UI. You can create using the CLI from the command line. You can create using Terraform, or you create with Terraform scripts. You can create using Ansible, or you can create using Pulumi. Or there is like different ways that you can create that. If you have a DevOps environment and you want your CI/CD to be creating the cluster for you, you can do that in different ways via API or CLI or whatever. You have like 2 options here that you'll be using the quick creates. The difference on custom creates is that allows you to select existing network information, and they have like, and you have more options that you can use to create the cluster. You'll be using quick creates because they create everything for you. Because the VCN is a virtual cloud network. The virtual cloud network, some providers call VPC, is actually the network that will be residing our resources and be using. The gateways that we use, the internet gateway for the nodes to access the internet. Like if you'll be pulling an image to create your pods or deployments, then you should use that. NAT gateway, in case like you be using a private nodes, you'll be talking about later, and Service gateway to connect to Oracle CI services and the cluster node pools. So let's everybody hit the quick create. Put a name. You'll probably be showing cluster 1. It's fine to use the same name that we're using. Make sure that you select the right compartment. In your case, it will be app dev or whatever name that you created. You have options for Kubernetes versions. You can select anyone. That example works with anyone. You can use the latest as well. That's one of the latest available on Kubernetes, and Oracle try to always get like close to the latest version of Kubernetes. And at that point, just to remind you that managed Kubernetes. Managed Kubernetes means that the control plane is managed by Oracle. You don't need to take care of your control plane. You just need to take care about your nodes, well, your worker nodes that we're using. Okay, and there is no cost for the control plane for this. You only like when you pay for the compute for the nodes that you are using. Creating a cluster. So let's go back to this. So we have a name, cluster 1, version. Private point, you set to for public, just to take care of just simplicity. But like you can have a private cluster as well, and you have a private point. And it's just like to access these, if you're using your Cloud Shell, you can connect to the private endpoint and do work from there and not be accessible on the internet. Or if you're using for a local machine, you need to have a bastion. And if you're using other tools like OCI Resource Manager to deploy the Terraform scripts, etc., you can create private endpoints to access your private endpoints. So let's leave like a standard public endpoint for Kubernetes. You are not be accessing the nodes directly. Like it's recommended to have private workers. That means that all the nodes, the compute will be created, they don't have public IPs. Select the shape. You can get the one that's offered to you. Like if you're free trial, you will be showing the one that you have available. And you can leave one, like that's pretty small for a node, but that's enough for our example. And also you'll be playing without scaling later. So better to leave that way. Have some extra options like here that we don't need to change right now. The boot volume, the standard is fine. If you want to change, it's fine as well. And that's the encryption that you can use. Like you can use intrinsic encryption, and they can use like everything, the secrets, everything is encrypted already, but it's managed by Oracle. That option allows you be a customer manager keys when you can bring your own keys and use it for encryption for everything. So that's the difference. You have like image verification. We're not using these. And if you want to access your node later, you're not be covering on this event right now, but you can generate a SSH key for you and just save your private public keys to SSH later. So let's click next. You can review everything. Because you're using quick create, that's simple. They are using the node network type is flannel. For people that know RSGs, they have like two options. You have a flannel, and then you have the VCN native. The difference is that flannel, they create like a different set of IPs, different from your VCN, and it's all managed by Kubernetes. If you change to the pod native, all the pods will be on the same network of the VCN. So that is some use cases that you need to use that. So let's leave like this and create cluster. So now that operation, that's what's doing is provision on the managed part of Oracle. They are preparing the control plane. That should be creating your cluster. So right now you can see that they're creating, and they are creating like every object that you need to use. Like they will be enabling the private endpoint and they'll be enabling the public endpoint. They already created the VCN. Like let's check the VCN right here. So that's your network configuration. You have a basic CIDR for everything, and then you have the subnets for each of the services. Like you have a subnet for the endpoint, have a subnet for the node, for the nodes, for the worker nodes, and that's used by the compute. And there you have a subnet for the load balancer to be created. Like if you create a new resource on Kubernetes type load balancer, they automatically create a load balancer infrastructure for you. And in our case, you'll be using Kubernetes ingress that you create like just one load balancer and be available for different services. Okay. So yeah, and in your console, you'll be able to navigate and see how that being configured, like the security leads, like what do they have access. If you want to change something, you can do that as well. For example, if you wanted to, you create like a public endpoint for the Kubernetes, but like you're not gonna want it to be available to everybody to access. So you can come here and change your IP address. see that we're using. That's just one example. Just like not make any change right now, or else like depending on your change, if you block your access, not to be able to do all the labs. Okay. Oh yeah, if you see here, the cluster would have the private and public endpoints. As soon as they created, they will be creating the node pool for you as well. And I selected there should be 3 nodes on that pool. Yeah, they're waiting for the cluster to be provisioned. So as I said, like that takes like 10 to 15 minutes. So yeah, it's creating. So let's get back to our introduction and talk more or less like the objectives and what to be doing before you go to lab 2. You probably saw already the outline that what you'll be doing, like right now in the step 3. And when you be actually deploying and working with the Kubernetes cluster, you'll be on lab 2 and 3. Okay, so as I said before, like the idea is to help you deploying applications and show you an example of using a not like just one service, it will be multiple services connecting to each other. Okay. Yeah, just like for people that's like just starting with cloud native, the main difference between the regular monolith architecture and the microservice architecture that when you run in a cluster like Kubernetes and etc., is that like you can create like a microservice that runs in different places, and you can have multiple microservices working together instead of like one big application running one machine. And that makes it easier to escalate, make it easier to deploy into different places. Like if you wanted to do a strategy of multi-cloud, when you wanted to have like one Kubernetes cluster in Oracle, another one on-premise, another one in a separate place, it's easier for you to make that connection and have the same service run everywhere, and use the network infrastructure to actually connect them between them. The demo that we'll be using, the MuShop, actually is running in a multi-cluster, multi-cloud environment. I give like a quick example, like when you finish the lab 2, you'll be able to see something like this on your environment. That's a demo environment. That one's run on OCI and Azure. So it's e-commerce, and you can see products, and you can add your cart and see your cart and logging, and have a different servers that will be deploying on these. Using the infrastructure, you have a load balancer that will be creating with your ingress. That example, they are using WAF and the DNS to get this address. And the ingress connects you to different services. You have a storefront that's HTML5. You have an API service that's Node.js, and you have other services like tracking that's in Go. You have the catalog service that's in Go as well. You have carts that's in Helidon, Java Helidon. You have the service orders that's in Spring Boot. You have the users that's in TypeScript, Node.js. You have fulfillment that's Micronauts, and you'll not be covering using all the infrastructure on G's lab because that can take too much and like it's more complex. But like you going to the repo or from the example, you'll be able to deploy everything if you want, and that means that you can connect all the servers to a HTTP database. You can use a service like API Gateway. You can have a function connect to the email service on OCI. And use the this bucket that's like the Amazon S3. You can use the object storage to connect to have your media to your website, and have also the OCI stream. That's a Kafka, managed Kafka service that you have as well. So you can have some details here as well. For people that ask why MuShop, oh, that's the thing that you come up, and that's a play of Mu, that's a symbol for microservices, and then the shop that's doing. That's similar. That's an example that you have on the internet that they call sock shop, that they use also to showcase microservices on internet. Give you an introduction on JS. You just talk like about JS and MuShop. I can go really quickly here on that slides. So yeah, no, MuShop is as I said, is a service that like uses a lot of showcase a lot of infrastructure services on OCI, and it can run on standalone, consume like their own resources, or uses other resources as well. So as I said, by MuShop, microservices, that's the symbol for micro. Then that's the way that to call is mu, and looks like meow, and that's you came for this. That's the better name that you that you get at the time. You try different names, and that one was the most fun. So you'll be deploying cloud native apps. That's the objective of this hands-on lab. And what is cloud native? Like cloud native is conjunct of technologies. There is a foundation that's take care of that standard that we're using. And for each necessity that you have like a service that like you be helping you. If you want something with network, you can use Calico. If you wanted to do Service Mesh, you can use like Oracle Service Mesh to be using something that's you want to manage. Or if you want to manage yourself, you can use things like Istio and have different services that you do that. Like one's like Helm and etc. On Oracle Native, you have different services to support you, how they manage okay, you have a registry. That's a Docker registry repository that's runs on your tenancy, and you can use that privately. Like you need to actually have some amount of you need to have like credentials to use it, or you can also deploy public things. Like if you're having problems to get like limits on Docker for your own production things, you can use your tenants that Docker registry. Have a resource manager. That's an infrastructure as a code solution running on the cloud that basically gets your Terraform scripts and run on the cloud for you with the worker on OCI, and also takes care of the state and all the changes that you'll be using. You have functions. If you wanted to have like a layer more abstract to run applications, have API gateway and other services like Service Mesh and etc. And you have services that helps you to work with the infrastructure, like the automatic monitoring, logging. You can have notifications when something happened on your cluster or something happened in your application. You receive a SMS or you receive a Slack message or something like this. The one that was not working really was the landscape. For people that don't know, the CNCF is a foundation that's has all the projects. Like the main one, of course, is Kubernetes, but you have like all the services that you normally consume on when you create like the infrastructure for cloud native application and microservices, and have like different services. You can go to the landscape website to get these, and you'll have a view of all the services that's offering, have all the providers, etc. that you'll be using. And also, now, and of course, you have all the providers that have also the options for managed Kubernetes, like you have on OK that you're using right now. Yeah, looks like my cluster is ready. So hope your clusters also finished. Oh, they are creating a node pool right now. So the cluster is available. If you wanted to connect to, that's what to be doing next. You just like the resource not be created because the pool is being created. And the pool looks like you have 3 compute nodes that have been created. They're just updating the files. So yeah. If you go to your menu, you can go to compute and instances. Make sure that you are in the right compartment. And then you have all the compute that have been created for you. And you can see that there is no public IP, just because like you select to be private nodes, private workers. So yeah, the computes are already available. And you have all the information here for that compute. It's just they are linking that with your Kubernetes cluster. Yep. For people that have already have the cluster there, you can go to the next step, that will be deploying the app. Oh, yeah, on setup, like, no, you can go to the next task. That's set up the access to the cluster. So if you see here on your cluster 1, and you have that button, access cluster. If you are using locally, you can use the local. You need to make sure that you have all the OCI CLI running and have everything set to be used. I recommend you choose the Cloud Shell because it's all pre-configured for your tenancy. You just need to launch the Cloud Shell. So yeah, you see there's a terminal that have access to things on this. Now, remember when I said that you can deploy your Kubernetes only as a private cluster, and to access from the Cloud Shell, you just need to select here and create a private network setup that connects to the same network of your cluster. You'll not be covering Gs on Gs because we're using public, so it's fine. So we need to copy Gs. That command uses the OCI CLI to create your kube config to access your cluster. Yep. So I have access to the cluster right now. I can do commands like kubectl and nodes. Oh, they are ready. Like if you do that and they didn't provision it yet, node pool is not like, yeah, there's active right now. That will be shown not read, you're creating. So that's the tree that you have. You have 3 nodes here and all the versions that they have. You can get more information. Like geez. Yep. It's out there. Because we're using the version 124, they are now using Creo. Now they're not all using the Docker scene anymore on Kubernetes, and let's use the new thing already. So okay, let's start it now with the deploying the app. So if you do or if you're following the labs, the task, you can see here, you can do commands to see if it's healthy, everything in your cluster, the scheduler and everything. It's fine, it's working. If you want to check the version of your client and your server, you can do the same. You see here version 124. It's fine that the client is using the 23 just for support. Normally you have the clients supporting versions like 2 below, like all the below ones and at least 1 on top. It's just for support, but you have all the features running well if you're 124. And you can get nodes. If everything is ready, you're ready to go. Let's go to the next lab. So as I said before, deploying apps, there is different forms that you can deploy, and MuShop specifically can deploy in different ways. You can run locally if you do like a Docker Compose. You can use like a regular Kubernetes and even a local one, like a Kind or Minikube, or even in another cloud provider like AKS in Azure or EKS in AWS, or one in DigitalOcean or whatever that they're using. On these labs, we'll be using Helm. That's a project from CNCF to run with Kubernetes to package things that we'll be talking more. Or you can have like more automated ways to do it. That's like deploys everything from Terraform, and they get the Helm charts and deploy for you as an infrastructure as well. Like that's optional and not to be covering on this lab. But if you go to the repo of MuShop, you'll be able to see it. On the introduction, you can see here more informations like about MuShop. Oops, that one. So yeah, that's the step-by-step doing with like different types of deployments and etc. And now also how to use to connect to the database and etc. I can share that link later. Let's go back to here. So deploy the app. The first step is to get the source that you have. That's the repo. If you want to check the repo of JSON here, that's the repo. And that repo, you have like inside the deployment, you have like basically that's for compute, not to deploy. That's like really basic deployment. That's like for use if you always free resources, like if you have a free tenancy and just like that. Because you have a free trial that you have more credits to do, you'll be using the complete and have different options to deployment here. If you want to check about the Terraform, you have here, the Terraform script to deploy it. You can use the magic button here. That's you click it, and in 2 clicks to deploy everything to your tenancy as well. And you'll be using the Helm charts provision on that case. Let me see if you have anything else in. Yeah, Cloud Shell looks fine. So I'll be cloning this to my machine. I mean, to my Cloud Shell. Yeah. Yep. You have here like everything that you have here now. I just clone everything here, so I'll be able to work. Here you have like more or less the structure of these. If you want to see the source of the services that you are using, you can go to the folder source. And right now, because we are deploying, you have the folder deploy that you have the options to do the deployment. So just a quick look here, like that's the sources. And for each server that you use, you have here the source code of that service. You have some information here as well. You can see that most of the stuff runs with YARN as well. I still need to convert some of them. That's like still on AMD, but that's something that's coming. So if you were able to do the kubectl get nodes and everything, means that you have your kubectl running like to access your cluster. If I do things like kubectl get pods -a that gets all namespaces on Kubernetes, you show that you have just the basic things on kube system. I do and I do not have any new namespace here. If you're running locally, I'm just like typing the full kubectl commands because like to be able to follow the lab. If you wanted to be easier to type things, I prefer to use that way. You can like just create a alias to a shorter command to help you. So you can do things like k get pods -a. Is faster to type. Okay, but kubectl you're still working on this. let's get the context that you're using. So if you see here, they create a context on the kubectl. That's name right here is the last digits of your cluster. So see, your cluster ID like is a brig OCID that you have, and the context gets the latest digit, so you can know that you are accessing the right cluster for this. I'll be creating like a namespace for MuShop for the application. And inside Kubernetes, it's good to have like different namespaces to organize your resources. If I get namespaces, you have like a new one that's empty, was just created. Every time that you create like a new resource, if you do not set the namespace, they normally go select to default. We don't want to do that. So that command right here, you tell us everything that all the commands that we'll be doing after this, you use the namespace MuShop. So if you do something like get pods and do not specify the namespace, they'll be showing just for the MuShop namespace. If you want to like someone different, like and kube system, they'll be showing in kube system. So that command you like just let's say the default one to be MuShop on deploying. So next step, you'll be setting up the application with Helm. When you in that architecture, you have all the microservices here, and that's what runs inside the MuShop namespace. But you have like different cluster services that helps you on the application. And for that application, you'll be using Prometheus, that will do sales metrics, Grafana, that's for visualization of that metrics and other things. You have the metrics service, the metrics server, that's support for outscaling. So when you have application that's you said that if that application, the pod that's running reach 7% of usage of CPU of memory, they automatically create like a new pod for you horizontally. And that will be created until you reach the maximum that you're supported by the node. And when you support this on the node, you can do also cluster out scaling. That will be creating new nodes for you on that rules. You can have more information if you search for Kubernetes cluster autoscaler. You have more information on this for Kubernetes in general that you'll be using. If you wanted to see something specific on OKE, you can have OKE cluster autoscaler, and have all the options that you have for outscaling your pods. That includes the cluster autoscaler. That's when you create like new nodes on the usage. You have the horizontal pod autoscaler that will be covering on these labs. And you have also the vertical pod autoscaler. Vertical pod autoscaler is normally used for applications that still need, like they do not run well with multiple microservices, but they wanted to increase on the single pods, like more memory and more CPU to use. And that helps you to do that. And you have like on implementation, all that forms. So you have the Ingress Nginx that you also be deploying. That is just to reduce the number of load balancers to be creating. Sometimes you want to just access to the same cluster and the same microservice, and you want to have like one load balance for each service. So you have an option to use the Ingress for this. The service catalog, that would be disabled. That's something that's getting deprecated by CNCF and not to be using anymore. The option will be disabled right now, so not be using this, need to remove from the lab. And also the cert manager. The cert manager is just something that helps you to generate the SSL certificates for you. You'll be deploying, you are not be including any host name on the deployment, so the access to your application will be using the IP address. But if you have a local domain, you can set your ingress to use your domain, like MuShop.example.com. And then if you set manager enabled, if you want to use a Let's Encrypt for encryption, they create that for you. The same one used by the example MuShop here. If you click here, you see that's that automatically managed by the certificates automatically managed by the cluster set manager, and they use Let's Encrypt certificate that's free to use. So now I'll be creating a namespace for the utilities for the cluster tools that we'll be using here. If you do get namespaces, you see that's now a new namespace, MuShop utilities. If you see here, they go directly to the folder deployment Helm chart. So I'm just checking because that's the first time that I have Helm running on that Cloud Shell. I need to make sure that they getting the latest information from the repos. So each service have their own repo, like microservices gets from Kubernetes, Ingress Nginx from Kubernetes, cert manager gets from the Jet stack, Grafana from Grafana, from Prometheus, etc. So they just get the base information to get all the image that they need for that services. Then on the step 3, you'll be installing that service on that cluster. So if you do again here, okay, get pods -a. I do not have any pods yet. So I'll be running that Helm command here. And that will be deploying all the servers that you need for a cluster. That ones are fine. It's just saying that's actually it's for Grafana. They are updating the new version that will not have these anymore. Just because they need to support the old ones, so they are changing these. And you are not on the 125 yet. So yeah. After you install the utilities, you probably will see a screen like this one. And because you're deploying everything, you can see here the information. Like if you know now I do kubectl get pods, you see the new pods being created. You have the sub manager, you have Grafana, you have Ingress, you have a matrix and everything that's needed for the Prometheus. If now I do kubectl get services, they have the regular service for each one, and the only one that says the external IP address is the Ingress controller. If I do get ingresses, they don't have any yet because like I just created the Ingress controller, but they don't have like any Ingress that use that Ingress controller. So if I go to that IP address right now, they've given me a 404 from the Nginx, from Ingress Nginx, because there is nothing set up yet. Okay. And on the result of the Helm that you install, you also can see all the commands that you'll be using, like what is the secret to access the Grafana, for example. So you need to run that command right here. So you go in that later because the English to access Grafana is not there yet. If you want to access, you can, if you're running locally, you can do just command to access locally without the Ingress. But that's like only if it's local. Right now, you're not being accessed. You just need to get the IP address of the Ingress. That's the one that you use it. So yeah, that's the same command. Like I do kubectl get service A, and I get everything and just get the IP address, or you can run this command to get specifically the one that I want. So let's take a look on the deployments on that specific namespace. Yep. Yeah, looks like that's a Grafana and message is still preparing. Yeah, let me see if there is any error on the pods. Grafana PS1 had a problem. I need to take a look on this later. Maybe something for the version of Grafana. Okay. When you go to the lab for that use Grafana, I can check these. Maybe something for the Kubernetes version. Yeah. Okay. Let's go to the next one. So the next step right now is to actually deploy MuShop on your application. Right? Until this point, you have open your tenancy, set up your environment to use, create the managed Kubernetes cluster. You have create out namespace that I'm going to use and install some server tools to access. That server tools, that cluster tools is things for informatics, Prometheus, Grafana, microservices, and everything that's you need to run everything. So right now, I'll be deploying the shards that's install JS. I'm going to install all the servers that you want to run right here. Some services that connect to the database, like catalog and charts and orders, etc. For GS Lab, because I'm not deploying the database, you'll be using it to mock servers. That means that everything that created use the in-memory database. They'll not be using a connect to HTTP. So that's why when you install, you set GS, you have a specific variable that you are doing mock service, and they emulate the data from the catalog, from the charts, and etc. The difference is if you stop the service, you lose like any chart, anything that you created. So you're not persisting the data anywhere. So let's deploy. But I appear to have some information on the chat. No, it's about the recording. Okay. So let's deploy MuShop. Yep. You just deploy it. If you now do okay, get pods, they are creating each service to run, like API, assets, chart, catalog, edge, events, fulfillment, NAS, order payments, and storefront, etc. If you want to see creating, you can do -w. So it's all running now. That's the same command that you run here. I'm using K just because it's easier to type, but yeah, we have everything running. Yep. Okay. So remember that's the ingress that you created. When you deploy with that Helm chart, when they deploy like all the applications, they also have ingress. Like, let me go to the source code right here. So if you go here, deploy, complete, Helm charts, and MuShop, that's where you just deploy it. On the templates, you have the ingress for each one. You have the ingress edge. That's create the ingress for you to access MuShop. And you create one for Grafana. That's the same thing, but using slash Grafana to access. So let's go to that IP address. Then you have your app. So if you follow all the steps until this point, and you'll be able to see your ingress, that's what you'll be seeing right now. You'll be not all that is coming from the catalog servers. The login when you create a new account, etc. That's you go to the user servers. When you want to the charts, that goes to the chart servers. And then you check out, they go to orders and everything. Because you use the mock, you're about to probably be more simple. Because they're using less service, but about all the same here. So at this point, you just deploy MuShop and you have everything running. If you do kubectl get ingresses, you'll be able to see the two ingresses that it was created. You probably need to take a look on. Yeah, Grafana for some reason, that's something that they need to debug together. Because the P that was crashing Grafana. So you just next thing you can like get deployments. You see each deployment of the stuff that you'll be doing. Right now, you just set to have like just one pod of each running. Deployment is different from the pods that's created, but it's right here, the pods. Everything's running fine on pods. If you want to inspect one of them, you can run those commands. That's like more to take a look on, like let's inspect the user pod. Yeah, that's commands just like to get the latest one and take a look on the information inside that pod. So we have our information that was created, like all the labels that was created. If it like this notation is just like it's prepared if you want to deploy with issue. They are pre-configured to issue as well. I'm not covering on this lab. The image that they're using, like where they get the image and the version of the image, the parts that the source internally use it, the health checks, environment information. Like, of course, you're not connected to the Oracle database. So that one is mock, like really, and that came from a secret when you're using. And then you collect your wallet, etc. And you have like everything that's happened to this pod. When you do kubectl get pods, you can describe like any of one, like one to describe catalog. You just copy this name and do kubectl describe pods. Yeah. And because like we can also use the label if you don't want to get everything, you can do kubectl. Yeah. If you don't want to type like the full name of the pod, because all the pods are ephemeral. So like if you will destroy one to create a new one, then you could have a different name. You can just do a command like JS, the shell app catalog. And that's why you normally create like labels and controls. So it's easier for you to reuse. Because like if you destroy this pod, that GUI here, you change. So, and also you can have like the logs, like kubectl get logs. You can have the name of the pod, or you can also do the label thing. Oh, sorry, there is no gets. I take off this. Yeah. So yeah. Right now the catalog is just reporting that it's healthy or not. And if you want to access one pod, you can also do that commands. Like let's use the one that's you use that you have the user pod. So you get the logs from the user. I can check the environment of the user pod. So if you see there's a lot of environment information from MuShop, from database, then you can see database is mocking and all the configuration from the other sources. Or just like do a ls. So yeah, they just show the files that use on the user source that you can see these all TypeScript. Yeah. Okay. The next task, the task 6, is just to see if you prefer, because the Helm is all dynamically, but you want to see everything that was actually deployed, like, for example, kubectl get deployments, and you can see specific deployments like MuShop catalog. You can expose like each one like to YAML. So they will show you the manifest of G's deployment. Then you have like everything that's normally used, like the .yaml for G's deployment. And like all the configurations that you use it. If you're using tracing, you can enable zipping as well. The ports, the CPU limits, and etc. You can get as well the service that was created for catalog. You see here, they get the IP address. They just run inside the cluster for security. They have the port that you're using and the port that you're using on the service. And that's it. And if you want to see all the YAMLs for everything, you can do this. You create like a folder .out. Right now it's empty, but like you export like all the YAMLs to that folder with that command. So you can go there and see. I'm not seeing this way. Let me use in the Cloud Shell, you have option here that's code editor. That's like the Visual Studio Code that you open on your cloud. You can navigate on files here. It'd be easier to then go to each one of the. Yeah, I'll just open. Let's see the files. So you have, if you're using your Cloud Shell, you can go to the MuShop and can go to the out folder. And we just generated from the Helm everything that you can see it, like you have the charts, like API, and you have the YAMLs. Like you're talking about the catalog source, right? So go to the catalog. Then you can take a look on the deployment. Right there. So you can take a look on the service, and you see that you get also the HPA. That's something that you go on the next lab. The HPA is set like for minimum of 1 and maximum of 10, and they are setting for the CPU usage. So according to the CPU, users, they will be doing this, be evaluating this. So if I do okay, get HPA set, I'll get that information as well. We'll be talking about that and the usage on each service. Okay. Okay. Appear that there's no questions, so I'm supposed that everybody deployed and is working fine. You can go to the next lab. And everybody knows how to use the Cloud Shell to do the Kubernetes commands, how to use the code editor. You can also do commands like top to see the usage. You can do like top node and see the usage of the nodes, the CPU and memory. You see that they're using like really small right now. And also can get from the pods. See that use a really low CPU and memory for each one of them. Let's see the JSON, the namespace MuShop utilities. Yep. Well, the one that uses more memory is the Prometheus server and more CPUs as well. Okay, let me close the code editor because I'll not be using right now. I see more information on the chat here. Okay. So before you go to the lab 3, I need to take a look on these pods on the MuShop utilities. That's GNP that's, and it's not related to the MuShop, it's actually the Graphite one. I think that's some related to the version, but yeah. Actually, need to do a describe. I need to see each one because 2 of 3 is failing. So 2 is running. Everything appears fine. Why is failing one? Yeah, there is the one in the dashboard one that's, they have 3 containers on that deployment, and the dashboard is the one that's failing. I put just the name of the container, just put the name of the pod before the container. Let's see if it's something for the version. What is the latest version of Grafana? Six 3214. Yeah, so I'll choose with no problem. Open edge a bit quicker. Oh, you're actually using a 632. That's not like that old. Okay. I try to destroy and clean to see if anybody else is having the same problem here. Okay, I just deleted the pod because Kubernetes they have a contract that need to be have at least one server that's running. They automatically you try to recreate the pod. Yeah, I think that's related to the storage. Well, you can use that for other environments. Let's follow. You have more 40 minutes more, and then you just at least to finish these. Let's go to the lab 3, task 1. So right now is really simple. The idea is to see that you have all the information of your cluster on the console as well. So here you have all the information of the version that was deployed. You have everything that's doing, like who is managing your secret keys, what is the answer of your endpoints. You have a node pools, and have all resources. You have a matrix, and that matrix shows you the maps for the cluster, and have the maps for the node pool as well. There's no enough information yet. Let me see directly on the compute to see if they are standard metrics. Yeah. So you have information for CPU utilization, the memory utilization on these, and disk access and disk write access. Like on the console, you have like all the maps that you needed. You can export that to Grafana as well. So yeah. You can see as well like which volumes, block volumes that are using on the specific node that you're using, information about the boot volume, and possible custom logs that you have been created on these. You also are able to see the cluster logs. If you have like a central manager that are using OS managed servers, you can also enable G's for on that instances. If you want to see logs, you can type like logging. Right now it's not enabled, but you can enable and you get automatic information about that logs in here. And like everything that's happened on Kubernetes and etc. start appearing here. If you want more details on G's, on documentation, there is a specific topic for observability that you can set up some use cases that are doing specific logging and show up in a specific logging structure that you can export to other systems that you're like Splunk or other that you can use in a company. You have here all that information. Let me share that link here on Zoom. So you'll be able to get on this later. Let me include it also on the Slack. And you have like different use cases here. That's how we will be doing things on this point. Let's go back to the labs. Graphite monitoring. For some reason, you're having problems with the Grafana that was working before, and now appear that Grafana only, that's the one that's failing, the one that shows the UI. I'll be showing the UI from the demo that I have. Together the password that I'm using on the Untitled Grafana, you can have here, you need to run that commands. That you automatically get the secrets, and that's the for the password. That's what is automatically generated. They will decode it and they will show you, and you just need to copy and paste to here with admin. Then you copy and paste the password here. I'll not be showing here, or else everybody will try to access using that. But you use the same password. Let me open another UI here and then use it. Information. Oh, let me copy the command. I'm typing everything. Okay. So inside Grafana, you'll be seeing something like this. And you have when you deploy MuShop, you have like I've included several. The screen is really small here. So that's the main screen of Grafana. You can click here in the home, and you can install you can import your own Grafana dashboard. When you deploy MuShop, they automatically like select some of dashboards and show you. So you have here some like cluster metrics. You can see getting information from Prometheus. You have like 45 containers running on this one, and you have a list of all these like Prometheus and each service, etc. and this one is using 3 nodes. You can select like the namespace that you want to see it, if not all that you'll be using. You have things like get CPU namespace, so you know that's how many memory that are using each of the namespaces, and all the pods, the amount of memory that you're using. You can see here, the one that uses the most is the Prometheus. If you want to select a specific namespace, like only MuShop, they'll be showing here like only MuShop, all the servers and the memory that you're using. You can see here that servers like using Go, really use like really low memory, even connects to the database. That one connects actually to the Oracle database. The story front like minimum that you use it. And others using like Micronaut or Halidon, they also do not use that much. Others use Spring Boot that's using more here. Also, yeah, that's specific for memory. Can some information about the horizontal pod autoscaler. Right now, there is no replicas that you're using. And you can navigate more. Let me take this. I have the zoom tab that's, yeah, was in front of everything, but now it's better. So yeah, you can navigate here, and you can go to the Grafana dashboards and see other ones that's like you like more. There's more information that's you wanna use. If you wanna enable as well, you can enable the ones for OCI and OKE to get information. Like they have pre-configuration, but you need to do extra steps to actually get information, like from compute and from etc. There is specific policy that you need to include in on your tenancy to use it. And like you have ones for specific services like Spring Boot or other services. Yeah, that one's not configured to the Spring Boot service yet. But... Okay. So yeah, the idea is you get the IP address, you get the password, and you just connect to the IP address that you get from the service, like from the controller, like G's. And do G/Grafana and admin and use this one. Right now, as you saw, that Grafana is failing. I don't know if some of the version should take a look more, but like with everything running, you see a screen like G's on the dashboards and the usage. The other task is related to scaling. As I showed before, you can see the HPA that you get like the configuration that you're using, and you can see on the replica set. Replica set says that the number of that's the Kubernetes is saying that's desired to have state running, and the current one. But like that's really small. Like it's really difficult to get more than this to get more. So I will be reducing the HPA of catalog that's one that uses more and start from the edges. So you can see they actually asking you to create like more pods. So let me change these, like kubectl, edit, HPA. Which one is first? Let's start from. I changed the CPU utilization that the average that I'll be using to actually just 30. Let me save these and quit. Yeah, they just reapply it. I think the edge as well. I need more on the edge catalog. change this to 30 as well. Yep. So try to get the PHPA. Yeah, that was reduced. So you can now do a load test and force this to change. Take a couple of minutes to the load that actually generates some load on this. You can see that the load pods are being created. If you want to investigate how that load works, you can go to the repo and source loads. Then you can see the deployments and the commands that are using for a change or anything like this. Let's see if it's running. Yeah, it's running. Oh, and they are already like set, like see, the API has 2 and the edge has 2 already. So they get API. Yeah. So the API got like 118% of the usage. Edge as well. Yeah, Storyfront I could not reach. The need to do less performatic so you can. So yeah, so now the API, the desired state is 2. The edge is 2 as well. If I change reduce this, they go all the way until they get like 10 pods running max. That's what you define on the HPA. Yep. So with Grafana running on in your cluster, you probably see G's. You probably see G's, the replicas and everything like running with more information. In a nice way to see it. Again. And if you have the cluster autoscaler and you have defined that's they just reduce your replicas, the targets now is less. They probably reduce some. And if you reach the max of nodes and after the capacity of the nodes, with cluster autoscaler, they will actually start to create a new node to deploy all that new pods that is running. Let me stop the loads. I just deleted the deployments. Yeah, I have the 2 loads running here. So I'll be deleting. Yeah, they are terminating the loads. So that concludes like all the labs that you have. You see that you have like a lot of material that you can go and explore more, like on the repo, on the documentation. You can see here like different ways and all the stuff that's running. In other things, like if you're deploying to the infrastructure, what you need. If you wanted to work with your observability, like if you're Grafana and if you wanted to deploy issue or the instructions, if you wanted to do like a canary deployment and see it, like that's how the MuShop works as well. That you can have like, here's like a quick tutorial on to make a change on the story fronts. What is the EPRS 150? It gets So, like if you want to do a change on G's and want to deploy in canary mode, you can see here as well. They'll have example like how to do G's using different versions with the changes. I have more details on monitoring, with the information that they're getting. Like you can use and how to use the CLI to get that information as well. How to create the health checks for each of the services. And some examples with observability and create like in the Meta Explorer with logs, etc. And also in Live Labs, you have like different options on how to do that. That's one example of DR, using traffic steering to send to different regions that are doing access and maintain the data, the data in sync. You can you also have the cluster running in a multi-cluster. That means that like all the deployments and the pods, they can be working with the same etcd. But that's more topics for other events. And also there is a option like how to deploy using Jenkins, and they use that in a pipeline for CI/CD. Do you have like any more questions or anything else? Can you go to the next lab that will actually be cleaning up and everything? So you have a trial tenancy that you can test like all the OCI services available. You just talk about the cloud native ones. Like to go that directly, you can go to developer services. You see that you have Kubernetes, you have a container registry, you have artifact registry that can also have your Helm charts and other artifacts there, and self-smash and other things. Let's go to the developers, have instructions and have everything. And that lab for to do cleanup is just like you probably have like $300 credits to use with your compute. And if you have the compute running, that you consume your credits. So if you want to destroy, that's what, and also the load balancer. One thing that I didn't show it, like when you create the ingress, they automatically create G's load balancer for you. And you can have like different shapes. You have the standard of 100 megabytes, but you can create like a load balancer that's flexible shapes. When you have flexible, like if you're running that in production, you normally want to do that because you don't use like maybe once a month, or in case of e-commerce, like during Black Friday, Cyber Monday, etc., that you have more access, and you wanted to pay for the load balancer with the minimum that you can have, like maybe start with 500 megabytes, like 500 megabytes, and go all the way to 8 gigabytes that do on demand. And so you'll be using always G's only if you increase the number of users accessing the same load balancer, that you'll be using the maximum bandwidth. And that's something that's pretty cool for companies. And you can set up G's on Kubernetes just using annotations. So if you do annotations, you can have a notation that says if you do a specific shape. So I recommend you always use flexible, and then you set up the maximum minimum that you be using on that flexible load balancer. And here you have all the notations as well that force to be like internal load balancer. And if you have a specific subnet, Kubernetes, they manage everything for you. You just like if you really need extra information, like the range of your flexible shape, or if you be using a network load balancer instead of a regular load balancer. That depends if you want to like a layer 7 or layer 4 load balancer for your application, depending on if your org is running, and how extra configuration that you can connect with the load balancer. So yeah. So if I destroy the service, you see that they automatically destroy load balance. I don't need to do anything here. Like, let's go to the cleanup. Let's at least all the releases that was created. So we created 2 releases. Let me increase here. You create like the MuShop and MuShop utilities that you have all the info that you're running. So you see something like this. So the first thing that you'll be deleting is the MuShop app. If you go here, okay, get pods now, you see that they're terminating all the pods. And if you list the releases, they deleted the Helm one. That's for MuShop. I can now destroy the dependencies, like all the cluster nodes. Like you get pods -a that shows all the pods. So yeah, the terminating, but you still have the ones on MuShop utilities. And if you go here, you still have the load balancer because the egress controller is running here and create a load balancer for you. So let me destroy the utilities as well. Okay, get pods. They destroy everything. They terminate just this one because they need to communicate to the OCI and change the state of the load balance that they created. Yeah, it's deleting right now. Yeah, and that's all managed from Kubernetes. Yeah. You could like I'm showing you like if you want to reuse your cluster for something extra, like now they are clean with pods. Maybe you just need to delete the namespace that they created, so but they are like before. And you do not need to do the steps if you go directly to the cluster and delete the cluster directly from here. Come here and delete the cluster directly. Yeah. That's what is the task for it is. So when I delete the cluster, automatically delete the node pools and the cluster. They're deleting. If you go to the node pool, you see that they delete the node pools and the work nodes they terminated. So if you go to the compute instances, then the nodes that you created, they will be terminating soon. Make sure the cluster. And if you have like any other functions, etc., you can just delete it if you create it. After delete the cluster, they will probably left behind your network for that cluster one. So maybe you want to also go to the VCN and terminate that VCN that you create for that cluster one. But first, they need to make sure that our objects have been deleted from here. And after we finish the deletion, you'll be concluding that the hands-on lab. Hope everybody follow and was able to install, deploy, and do everything here. If you have any extra question, you can go to the QA, and I think Tara will be doing a live QA, right?
Thank you again, Adao, for this fantastic workshop, and thank you all for joining us here today. We hope to see you again next